Thanks for watching our presentation. We are TEAM4. First part is review of problem statement. We try to solve the problem of key pop. As you guys already know, attacker can steal the pop's code during operation of remote controller, copy this and access, and can take a car. To solve the problem of key pop, our team think of the idea. What if changing pop's code whenever using a key? So we focus on updating key time to time while driving car. We can make secure channel and update key. Unless attacker keeps tracking car, it is not possible to grab the secure key. But what if there are not enough time for generating and updating key? Or what if attacker can access physical remote controller and possible to press the button and copy the code? To solve this problem, we think of the OTP, one-time password. Maybe most of you guys have experience of using OTP when using mobile banking. It changes secret key periodically, harden the security. By adapting this, we can prevent the weak point we said before, but we need long secret code, not 6 numbers. Also include the character, so we name it mix the OTP.
Okay, let's take a look at how we started. Today's IoT applications in automotive industry are widely used. Among these, we focused on key fob problem. In this problem, what we paid attention to is that remote signal to open car is unchangeable. Then we thought, is it possible to update remote signal? If possible, then it would be much safer than previous one. IoT is Internet of Things. That is, IoT car is also subject to Internet 5-layer model. To implement for secure communication, we should consider those 5 layers. Among these, we chose socket between application layer and transport layer. Our ultimate goal is to update remote signal periodically, so we can prevent car theft. There are many ways to contribute to this problem. Actually, we considered many ways such as modem, waveform generator, but we conclude the implementation of secure socket. Why socket? Socket is the interface to connect client and server. A data path is created through the socket. That is, socket is the fundamental factor in IoT car key communication. Then how we update secret key? We introduce TOTP, time-based one-time password. TOTP changes the password based on time interval. By using TOTP technology, we can update secret key.
Let's code analysis. There are 2 codes, client and server. First, we see the client code. In the client code, write the server's IP address and port number, and then we run this code. They are ready to connect. When the connect is complete, there is some message on console, server connect. And the client read their key from clientkey.txt file. The reason that we use text file is it is so useful to update their key. After the client read the key, they send this key to the server. This is the server code. Server code, we write the server IP and port on the server code same as the client code. And the server needs to read their key same as the client from the server key.txt file. The reason is the same as the client key. And the server received the key that the client sent. In this code, 0 means client wants to disconnect. It is similar with the pushing the lock button on the car key, and its signal is 0. And this part is update the server key. If client key is equal to the server key, in the server they start to update the key, and then we should set the hash mode to make some OTP key, and we should set the refresh time and get a renew OTP key, and this renewed OTP key is the new server key. So server should write their new key on the server key.txt file. Then the key update on server is finished. And the server send this new key to the client. Also, this part is when the client key and server key is different. Then the connection is over. And the client get the new key from the server. There's the code named decode. The reason we use decode is the process of the getting the new key. There is as some alphabet B and apostrophe. So we should use the decode code to remove some B, and we update the new key on the client.txt. It is same process of the server, and the client wants to disconnect. To disconnect with the client and server, we use the keyboard interrupt, because keyboard interrupt, when we put the Control C, the code goes into the accept. When we don't put Control C, then they just process on the try. Then client sends 0. This is before I said that the signal is 0. It's same with this signal. 0 means the client wants to create the connection. The client key was updated by last renewed server key. This is the OTP code that produced the new server key. We could renew the key in period by refresh time. Before we set the refresh time by 5, that means the OTP code was for the 5 seconds. The basic algorithm is the hash function. We could set these hash functions too. This is the overall code of the server, and this is the overall code of the client. Let's we analyze the result. The first one is when the server key and client key has the same value. When you see this left top side, they have two same key. Then when we see the client and server, the server update their key, and the client could get this updating key. So when the client push the Control C, then the connection would be over. After this connection, let's check their key, we could see these two keys have the same value. And the server key and client keys has some different value. They couldn't connect between the client and server. We could analyze this process on the car and car key. First, car and car key and car are ready to connect, and these two call their key number. The third car key sends its key number to the car. If these two key numbers are different, then it couldn't be connected. First, in the car renew its key number through OTP method. The car sends its new key to the car key. The car key get a new key and it renew its key number. And the process 4, 5, 6 are getting repeated. But when you press the lock button, the car key sends some signal to the car and the connection will be closed. And maybe these two keys have the same value through OTP method. The car sends its new key to the car key. The car key get a new key and it renew its key number. And the process 4, 5, 6 are getting repeated. But when you press the lock button, the car key sends some signal to the car and the connection will be closed. And maybe these two keys have the same value.
The roadblocks and challenges. There are two kinds of challenges which we overcome and yet overcome. The challenge that we overcome about the code are the implementation of repeatedly sending the key and implementation of this connection. And challenge that have been overcome yet is implementing with different two devices. Implementation of repeatedly sending the key. Using HMAC and hashlib package, we generated a 6-digit random number. But every time the TP changed, we have to send the key generated by the TP to the client to update. So we use time package and the code time.sleep. And the keys made of OTP were repeatedly sent to the client and stored by the client every time the TP was updated. Implementation of this connection. It has yet to implement when the car key sends a lock signal, the connection disconnected. To implement this code by setting the action of pressing the lock button to receive an input of 0. When receiving this input, we disconnect the connection. This action is implemented by if, else, and break. The challenge yet overcome. In rear key fob, car and the key are the different devices using RFID communication. The communication using RFID devices is difficult to implement, so we use Python socket programming. We must implement in different devices which have different IP.
The first project that our team started was the construction of an encryption protocol for communication between the car and the RFID car key. However, because of the difficulty of preparing a car with RFID reader and server computer, two alternative laptops are connected to the same Wi-Fi and transfer the password to data, and the password is updated according to the laptop's usage time. So we use two laptops instead of a car and a car key with an embedded system. And we work on the project with Wi-Fi on behalf of RFID communication.
This is our project timeline. Now, let's take a look at the next steps. Since we are not completed the whole code of TOTP, we just show the feasibility of connection using socket by just using the built-in OTP algorithm which produces 6-digit numbers. As we need key with longer lengths and mixture of number and characters, we'll keep developing the mixed TOTP algorithm. And we're gonna enhance the stability of update too. In case of users not using car enough, key updating barrier is reasonable. But when updating pair with some device problem, there is a need to show the message to user. Also, we are thinking of the generation of random number by gathering information of car status, like transition of steer wheel, pedal, or mixture information of air and gas, which gives more randomness to code. Last is reference. Thank you.